Okay. Hello, everyone, and welcome back to HCI-space, a podcast where we explore the world of human-computer interactions through conversation with people designing the future of how we live, learn, and connect with technology. I'm your host, Aditya Singh, and this week we're joined by Professor Harrison Goldstein, who is an assistant professor at the University of Buffalo, specializing in HCI. Hi, Professor Goldstein. How are you today?
I'm doing great. How are you?
I'm good. So yeah, before we dive into your recent work, I'd like to start each episode with the same question. It helps us understand not just what you work on, but why. So with that in mind, how did you get into HCI, and was there a space or project that really pulled you into this space?
Yeah. So my research is not just in HCI. I do HCI and an area called programming languages. So programming languages, you think it might just be like inventing Python again, but really it's about a bunch of math behind how languages like Python are designed. And I started off my PhD doing just that. I was focused on programming languages. That was what I worked on. And I got to a point where I was wondering sort of how is the work that I'm doing right now actually impacting real people? And I wasn't sure how to answer that question. And it turned out that a professor named Andrew Head, who is an HCI professor at Penn, had just started there when I was sort of halfway through my PhD. And my advisor told me, go talk to him and see if see if this HCI thing, which neither of us knew anything about, has ways of answering questions like, how does this impact real people? And it turns out HCI does absolutely have tools for helping you to figure out how your research is going to impact people. And so in my work, I've kind of borrowed tools from HCI over the years to both decide what to work on, to figure out like what problems actually matter to people, and to figure out if the work that I'm doing is actually having the impact that I want it to have. So that's how I sort of got into this space, and it's been really fun to play around here.
Actually, that's very interesting. Thank you for sharing that. And a lot of people might not even know what HCI even is. Do you think you can explain it in a way that would make sense to a high schooler?
Yeah, I mean, I don't think HCI is any one thing. If you go to conferences on HCI, you have people doing, building systems and sort of figuring out how those work for people. You have people doing basically sociology or anthropology research on just how people interact with technology. So what I think, like at a very high level, HCI is about how humans and technology somehow interact. But beyond that, I can't get any more specific because there's so many things that means. And I think that's really exciting. I think that's why HCI is so cool, is because you go to an HCI conference and you've got people with robots and you've got people with cool software systems and all sorts of stuff. But yeah, any more fine-grained definition doesn't really exist, I think.
I see. It's a very interesting way of putting it. And also now I kind of want to dive into your research, and specifically in one of your papers on proof assistance, computer tools that help mathematicians and programmers check every step of a proof. I think you're really focusing on how people actually use them in practice. And a lot of people really seem pessimistic about these tools, saying they're hard to learn or tedious. But if people really invested the time, do you think they could eventually help us crack, these tools, could they help us crack, big unsolved math problems? Or is their role more of like passive checking what humans can already come up with?
Okay, so there's a lot of parts to this question. I'm going to try to unpack it. First, I should mention that this paper you're talking about, the first author and the person who led the project is my colleague, Jessica Shih, and she's awesome, and folks should check out her research. I just wanted to make sure I said that. Proof assistants are really cool technology, right? They're like you said, they're a way to check mathematical proofs using code. And I agree. The pessimism that people have about these things is that they're too difficult to use. I think there's a few ways to look at that. I do think these tools can be used to crack big unsolved math problems, and I think they can be used by mathematicians to great effect. One of the a very famous mathematician, Terence Tao, has been streaming himself using a proof assistant called Lean to do some of his math work, and I think there's some growing momentum there. At the same time, I think there's, we're talking about HCI, and one of the big things that I think is so amazing about HCI is that we can work first from the people who are going to be impacted, kind of backward to what technology they need. And I think in the case of mathematics and proof assistants, it's not clear yet whether all mathematicians are eventually going to want to use these tools, or whether maybe there's just some kinds of math or some sorts of mathematicians where it's not a good fit, and there needs to be some other kind of tool developed, or maybe there's no tool that needs to be developed and they're perfectly fine doing their work the way they're doing it. So I think it's not so much about people like having to really invest the time. I do think like we should be designing these tools to be as useful as possible for the people who are trying to use them. And I think some folks are just going to get more out of it than others because they're more inclined to think a certain way. Yeah.
I see. Yeah. So yeah, I just want to like go a bit deeper into this and wanted to understand, because like obviously a lot of people are pessimistic. So are like, for these tools, are there like manuals to understand these like this tool, or is it more of like a kind of like a domain specialist thing where you have to like prompt engineer and kind of figure out how to use it?
So there's no prompt engineering really, but I think there are manuals and there's tutorials. So my PhD advisor, Benjamin Pierce, wrote a book, an online textbook called Software Foundations, which teaches how to use a particular proof assistant called Rock. There are also books on Lean, and like these are things that people can learn. They do require a lot of time and experience. It's not, it's not the kind of thing you can kind of pick up in a weekend. But there's certainly a tool that an expert, a person who needs to use this for their job, can get used to. I think the pessimism comes from people who either don't want to use this tool, which is perfectly fair enough, or else they do want to use it, but they sort of think it's the kind of thing that is supposed to be usable in a day, and like I don't subscribe to the idea that kind of every tool and every user interface should kind of be immediately intuitive. I think there's some tools that are just going to be hard to use because the thing you're doing with them is hard, right? No one looks at like a welding machine and says like, well, anyone off the street should be able to just figure this out, right? Like it takes some expertise, and I think that's okay, and we should be trying to make these as usable as possible anyway.
I see. Okay. All right. Yeah. And in another one of your papers, you introduced FEDT, a tool that lets researchers write their fabrication experiments as code, which then generates like a flowchart and machine files and like a spreadsheet, I think. But for this to work, the steps of an experiment have to be written in code. And some people might kind of think they might find that intimidating. So like from your experience, does this extra effort upfront pay off later, or does it risk scaring away people who just want to get like their hands dirty in the lab?
I wonder if you are one of the reviewers who reviewed the paper, because they had very, very similar questions. So I think in some ways, I think PhET has been a little bit misunderstood. I think my goal is not to have everyone who does a fabrication experiment, they must need to know how to program in order to do their experiments this way. Right now, one person on the team at least does need to know Python. And that's not uncommon in labs that do fabrication research. It's not like not everyone knows how to program, but lots of people do in that space. But like what PhET really is a foundation. It's a thing to build on. And we hope that over the years, people will build user interfaces that are more drag and drop, that are more kind of intuitively useful to a person who doesn't know how to program. And that the underlying kind of formal structure there, that the foundation helps everyone to kind of make sure it's all like correct at the end. So like, yes, I think there's a way in which this can be intimidating to folks, but I think even right now it's not unusual for someone in one of those labs to know how to program, and then later on we hope that no one will have to be able to do that. It's just this is a stepping stone to a kind of larger goal.
I see. So like by stepping stone, do you mean like PhET is just like the beginning of, you know, having like people write code and then it kind of writing the flow charts and like generalizing the steps? Are you working towards something that would like simplify the way users interact with, you know, these types of tools, so it becomes easier for people who might not even know coding to like interact with these tools and generate the same types of outputs?
Yes, that's the idea. So by the way, the first author on that paper is Valkyrie Savage, and she is one of the coolest researchers I know. And her team is working on that, as well as some of the others on the project are thinking about that kind of thing. We're not 100% sure what that user interface should look like, and we need like more help from the community and from users of the tool to kind of help to understand what that user interface should be. But like, ultimately, I think the goal should be a kind of no-code interface to PhET. But that's still ultimately under the hood is PhET, so that we can get all of the benefits of the language right now without necessarily the drawbacks of someone needing to know how to write code.
I see. So in the future, maybe like 10, 15 years down the line, do you see this as like a possibility in maybe college labs or even high school labs?
Yeah, I think so, and I don't even know if it would take that long. I could imagine in the next few years this being the kind of thing that a professor in a university, they have some undergrads, and they're working with them to use that. I think and high schoolers who are sufficiently interested in figuring it out, I think could as well.
Yes.
Yeah.
Okay, and yeah, for our viewers, maybe backtracking a bit, could you explain what PhET is?
Yeah. So PhET is a language that allows a person to write down very concretely how to carry out the steps of a scientific experiment. And specifically, we're focusing on experiments in 3D fabrication. So if you know about like 3D printers or CNC machines, things like that, sometimes researchers are doing experiments on those kinds of machines. And the goal of PhET is to allow them to kind of unambiguously state, you do this, and then you do this, and you measure this, and to sort of follow the flow of that experiment through very concretely. And the reason this is super important is that if you just do an experiment, you just like try some stuff, and then later on you go to write a paper and you write down the steps that you sort of remember having carried out. And you write them in English, so maybe you were a little bit imprecise here and there, and you just sort of assumed that your reader was going to figure out what you meant. Later on down the line, if someone wants to do the same experiment again, maybe they can't because you misremembered a step, or because you were a little bit vague somewhere, or something like that. And so PhET allows you to be very specific and very concrete about how your experiment executes, so that people later on have a very easy time replicating your results or using your experiment as a kind of starting point for a new experiment.
I see. Also, to kind of follow up, this might be out of the scope of PhET, but I was just curious to know, do you think maybe there'll be like a similar tool that you feed these instructions into could, you know, potentially predict future outcomes of an experiment? Like, do you think that's futuristic or?
No, I actually think so. This is a thing we've thought about. So in my in some of my work, I do a lot of work with kind of random data generation.
Mm-hmm.
And one of the things we want to do with PhET, which we haven't quite implemented yet, but which I would love to do, is simulations. So you write down the experiment and then you simulate it a bunch. And you can bake in some assumptions to that simulation so that you can kind of, you say like, well, if the inputs to the experiment go this way, maybe the output goes that way. And there's a bunch of people right now thinking about that kind of thing. I think like there's a limit where at a certain point you really do need to just do the thing in the real world, right? Like I think it can be tempting to trust kind of simulations of things as like, oh, that's probably good enough. I think we know what's going to happen. But it's really important that people actually do the experiment in the real world. But as a way to kind of check that you've set up the experiment correctly, I think simulation could be really, really useful.
I see. And yeah, like based on your research, both PhET and the assistant the proof assistants, is there anything like surprising in your research that you found?
Oh, I mean, we find surprising stuff all the time. I mean, this is one of my favorite things about doing research and being an academic, is that like we get to find surprising stuff around every corner. You know, I sometimes tell people like my job is to learn cool things, and that's awesome. I just love that. Let me pick out one surprising thing.
Sure.
Let's see. So from the QED and context work, the work on proof assistance, one thing which was a little bit surprising is that, like, if you think about, so the way proof assistants work very, very broadly is that you write down your proof, and then the system checks it. And if it checks it, that proof is correct. It doesn't matter how you got there. If the system says good, it doesn't really matter what was in between, what that proof looked like. And you'd think then that means that people don't put a lot of effort into making that proof look a certain way. Because at the end of the day, if it checks, it works. And there's, right. It doesn't matter necessarily for the correctness of the thing, what that proof looks like. And yet it turns out people care a lot about what that proof script looks like, because they need to be able to maintain it, right? If they change one of the inputs to the proof, if they change like one of the definitions, they need to be able to then update the proof so that it is still correct. And they also just care for the sake of kind of communicating to their colleagues things about how they did their proof. And so, it turns out that in places where you might naively assume like, oh, no one's going to care what that looks like we can just ignore that part of the process, there's a bunch of interesting stuff going on. And people talk about that a little bit, but I think kind of watching in that study, watching people putting a bunch of effort into that proof script was like really surprising and interesting to us.
I see. And also more on the proof kind of assistance, I was wondering, would this is like eventually be automated enough to be, you know, for the tool to kind of produce its own proofs based on like ambiguous kind of like you basically tell the system what you want, like a generic math formula or like a proof you want, and then it can just generate it for you with like 100% accuracy.
So yes, absolutely, and people are doing this already. So so for very simple theorems, for very simple mathematical statements that you might want to prove, there are tools already that can very reliably just prove those. And I won't get into sort of how, but that happens without the help of LLMs or machine learning or AI or anything like that. It's really very clever programming that you can use to kind of automate certain kinds of proofs. Then you have more complicated proofs where it's unlikely that those tools will be able to solve the proof immediately, but people are using things like large language models and AI to help structure those proofs or help translate a proof on paper into a proof in the proof assistant. And mostly these things are, one of the things that's so great about this is like, if you are very careful that you've written down your mathematical statement correctly, then if a large language model generates that proof and it gets checked, it's correct, right? You don't have to worry about hallucinations or anything like that. If the proof assistant says the proof is true, the proof is true. And so I think this is actually a really exciting thing that people are working on, and they're being able to prove some pretty impressive theorems with the help of both very clever programming and AI. So yeah, I mean, I don't necessarily believe that we'll get to a point where like all of the theorems that we I don't think we'll get to a point where all of the theorems that we want to prove are just somehow automatically provable. I think, you know, mathematicians do a very hard job. But I think we'll have help in that task, and I think that's exciting.
I see. It's very interesting. And yeah, now coming back to like more general questions, a lot of people are really cynical about, you know, building trust within the AI community. So do you think there are any ways we can, you know, build trust with people in technology?
I think the key to building trust is education. I think that the most important thing here is that people need to understand what the technology that they're using is doing. Because I think people trust sometimes, like, you know, ChatGPT when they shouldn't, because they don't understand how it works. And also people mistrust certain kinds of technology because they don't understand how it works, even though actually it's like really there to help them. And so I think education, and I also think, you know, empathy, actually meeting people where they are and not trying to kind of put your worldview on someone else. You know, if someone doesn't want to use a particular kind of technology, maybe that's okay. Maybe they don't have to. But yeah, I think education and I think empathy are the keys there. And it's hard. It's very hard, but it's worth striving for, because technology has so much power to help people if we can make it work for them instead of work at them or work against them.
I see. Yeah, I agree with the education. Yeah, so, I mean, what part of the future of HCI excites you the most, and what worries you the most?
I mean, I think what excites me in a sense is the popularity of the field. Like the fact that HCI is this big, cool area with lots of great people doing lots of great research means that people are thinking about people and not just thinking about technology. And I think that's really important. Like if we're gonna do this thing with all this technology that we're building, like we have to have people in mind the whole time. I think what worries me, what scares me, is that like it's very easy to lose sight of that. Like even among HCI researchers, I sometimes see work where I'm like, did you really think through, like, is this going to make the world better or worse before you did this project? And you know, I certainly won't name any names, but I think you know, that my call to action for anyone who's doing basically anything with technology is like, think for just a second, like, is this going to make the world worse if I build this? And then if the answer is yes, don't build it. Go do something else. Like, it doesn't matter that it's cool. Like, you know, I love doing things that are cool for the sake of them being cool. But if it's making the world worse, like, just don't.
I see. And yeah, if you could give one piece of advice to young people interested in technology that impacts humans broadly, what would it be?
Well, I think what I just said is one of them, right? Like make sure you're not making the world worse.
Yeah.
I also think you don't have to follow the trend of the moment. Like AI is really hot right now, and AI is probably going to be hot for a while longer. But like AI is not all of computer science, right? And you know, before AI was hot, crypto was hot, and before crypto was hot, something else was hot. And like there's these hype cycles. There's these things that in technology are particularly popular in a moment. And like in HCI, the same is true, right? So my HCI is kind of a microcosm of computer science more broadly. But you don't have to do whatever's hot right now. You can follow what's exciting and interesting to you. And you know, eventually at some point, you might want to engage with the thing that's hot right now because there are opportunities around it. But if you just only ever focus on the thing that's hot right now, you're going to miss so many really interesting things around that stuff. And I think it makes me sad when I see that like people going into college are kind of all want to do the same thing. And like there's so many other cool things that they could want to do. So that's my advice. My advice is like, look broadly. You don't have to be focused on what's hot right now, because in 2 years, maybe something else is going to be hot. So just do what's exciting and interesting.
I see. That's very insightful. But yeah, to wrap this up, thank you so much for your time for, this podcast. And do you have any final words?
I'm so excited that you and other high schoolers are like excited about this stuff. And I really hope that folks go out into the world, build technology that is good for people, not bad for people, and focus on things that make you happy and make you inspired.
All right. Thank you so much for your time. And yeah.
Yeah. Thank you.